Alright, so if you don't know, the GMTK Game Jam event just finished up last weekend, and I figured in celebration of that event, let's go ahead and make a video going over 2 tricks that I like to use in my Game Jam games that boost up the polish and the visual fidelity, even of just simple pixel art games. And these are really great tricks because what happens is usually in game jams you put polishing and visual effects last on your to-do list, or you push it off to your artist and you say, hey, can you make this look nice? Well, in a game jam setting especially, you start to run out of time and these items tend to be the first ones to be dropped. So I'm going to be going over 2 functions that we can use in Game Maker that will make it very easy to add simple polish and just some dynamic motion really into your Game Jam games. Now, I'm not going to be going over the math of these 2 functions. I'm just going to be going over the implementation and how to program them, because I feel like a lot of people see these words lerp and sine and cosine and are a little intimidated when in reality they're very, very easy to use, and I use them all over the place to look nice. So let's go ahead and get started. So if I go ahead and run this project, I have a simple little test project that I've put together of a little character that runs around the screen. All right, nothing too crazy. And you can see I have this gem here, but this gem looks relatively boring. So how can we make this gem look a little more interesting? Well, the first thing I'm gonna do is I'm gonna go over sine. Now, what is sine? Sine is a math function that you've probably seen in your math classes, and you pass in some sort of value here and then it spits out something. You might be like, oh, I could put sine of pi and that's going to put out a value, or sine of 1 and that's going to put out some sort of value. But we're going to be using sine to generate dynamic motion. So let's go ahead and open up our gem objects, and I am going to create a value. Now, the first thing that I want to say is let's just call this float iter. Now, what does this mean? This means float iterator, and I just call it iter for shorthand because I type these out a lot, and I'm going to set this equal to 0. Now, this is a variable that's going to be used to keep track of the way that sine and cosine are going to affect the positioning of this gem. So what we're going to do here is we're going to try to have this gem object kind of float in space and look like it's just kind of bobbing and levitating above the ground a little bit. And one way to do that is add some smooth motion using sine. So we've created our float iter variable. The next thing we need to do is we need to say float iter speed, and we're going to say 0.1. All right, so now in our step event, I'm going to go begin step, and I'm going to say float iter plus equals float iter speed. All right, nice and simple. So now all we have to do is in our draw event, I'm going to come here and I'm going to say, instead of drawing self, let's go ahead and say draw sprite, and I'm going to say sprite index, image index, because we're not changing those at all. And our X position is going to stay the same, but now we're going to make some modifications to our Y position. So normally we could just put Y here and this would draw the same, but all I'm going to do is I'm going to say plus sine of float iter. Now what's happening is what we're doing is we're passing in this variable that's constantly changing into our sine function. And if we take a look at our begin step, you can see that float iter is always being incremented by float iter speed. So we start at 0, and every step we add 0.1, and then we pass this into a sine function, which is going to essentially clamp this value and return it as some sort of value between -1 and +1. So what we're going to do is we're going to get some sort of value between these 2 numbers. Well, if we go ahead and add that -1 or somewhere in between 1 to our Y position, you'll see how we can start to increase and decrease the Y position by this value, and so that it looks like it'll start moving. So if we go ahead and run this project and we look really closely, you can see that we can see the gem bobbing a little bit. Let's go ahead and draw this guy scaled up a little bit. All right, and if we go ahead and run this again, you can see that our gem is just ever so slightly moving. Well, how would we increase the size of this? Well, what I can do is I can say var amplitude equals 5. And now what I'm going to do is I'm going to come through here and I'm going to say y is equal to y plus our sine float iter times our amplitude. And if we go ahead and run this again, you can see that now our gem is really starting to bob. And what's really great about this is it has a very smooth motion and iterates between this -1 and +1 value constantly, creating this nice bobbing effect. And of course we multiply it by 5 to give it a larger amplitude so that it starts to bounce around nicer. Okay, so what else can we do? That's pretty much it, right? That's a full beginning to end implementation of using Sign to create polish. But you can do so much more with this. You can implement this in places that don't just affect Y position. For example, let's say we wanted to have our rotation. Well, normally we draw our rotation at 0, but let's say Sign of float iter. All right, we aren't seeing anything, so it's kind of small, so let's go ahead and multiply this by amplitude. And you can see that our gem is starting to rotate a little bit. Now, how this rotates will be based off of your origin of your sprite. And I don't know what the origin of this one is a little offset, so if we go ahead and fix this, we should fix our rotation so that it doesn't look so uneven. Let's go ahead and say we put in a secondary gem. You will see that both of these are moving up and down and rotating. They're doing everything in sync, and maybe this is something that you don't want to have in your game. Maybe you want each of these to be offset by a random amount. Well, this is going to be very easy to do. All we have to do is on create, instead of setting our float iteration to 0, we can just say irandom of 100. And if we run this again, you will see that these are now completely offset. Now what's happening here? Well, instead of starting our iteration at 0, we're starting at a random number between 0 and 100, and we just happen to grab an integer. We could just remove this and it could be a float point value and that would still work out. And what's happening is this is kind of acting as like our starting point. And then every frame we increment it by a small amount, and then we draw it to the screen based on that. So that's a very simple way to add some sort of offset into our values so that they start to look a little bit different. Okay, so that's pretty much all I want to go over with Sign. You can do the same thing with cosine. It will produce the same effect. So I use Sign for pretty much everything. I know some people like cosine. You can really use either. It shouldn't make much of a difference. You're going to be getting the same type of effect. All right, so that's pretty much everything I wanted to cover for Sign and cosine. Next, we're going to jump into lerping and using the lerp function. Now, lerp can be used for any sort of type of motion. So let's go ahead and open up our game controller, and we're going to implement an example of this and learn all that we can about lerping using this. So what we're going to do is we're going to create an in-game menu that's going to start on the left side of the screen, and when we open it, it's going to slide to maybe the halfway point of the screen. Okay, so let's go ahead and create some variables. I'm going to say panel x equals 0, and I'm going to say panel width equals surface, get width of application surface. So basically I'm just going to say draw this at 1/2 the size of our application surface. And inside of our draw event, I'm going to say draw rectangle at panel x 0, panel x plus panel width, and surface gets height of application surface. And let's go ahead and draw set color. Oh, let's do the alpha too. Let's set that to 0.8 and draw set color to black. All right, let's make sure we set everything else back. So 1.0 and set this to white. So if I go ahead and run this, you'll see that we have our panel showing up on the left side of the screen. Now there's some depth issues, so let's just go ahead and say step depth is equal to -1000, and this should fix that depth issue. Okay, so now you can see that we have this black rectangle representing our main menu that is covering up half of the screen. Well, what we can do is we're going to say, let's go ahead and add another variable. We're going to say open equals false, and we're only going to draw this if our panel is open. All right, so now what we can do is we can add a step event, and we're going to say if keyboard check pressed, VK enter. We're going to toggle our open state. So we're going to say open is equal to not open. So if I run the project again, you can see that we can press this to open and close the menu. But this doesn't look very good, right? Because no menu just disappears and reappears instantaneously. And so let's go ahead and make this look nicer by adding in some motion. So what we're going to say is instead of drawing this if it's open, we're always going to draw it but we're going to say panel X is equal to lerp panel X panel target X of 0.1. Now, there's a lot to unpack here. First thing, we notice that we created a new variable. So let's go ahead and add that in. We're going to say panel target X equals 0. Okay? All right, so what is happening here? So we're saying panel X equals lerp panel X to panel target X by 0.1. Well, let's change this up a little bit. Instead of doing this, let's say we want to, panel X is going to be a lerp of 0 to 100 by let's just say 1. So if we go ahead and run this, you'll see that our panel is shifted over to the right by about 100 pixels. Actually, it's exactly 100 pixels. Because what we're doing here is we're saying, okay, the panel X position is going to be equal to lerp starting at 0, ending at 100, and at 100%. So this one here is going to be a decimal representation of our percentage. So 1 equals 100, and 0.5 is going to equal 50%, okay? So this is going to be a decimal representation of our percentage. So if I change this to 0.5, you will see that we are now left a little bit more, half that distance. So we're actually to the right by 50 pixels. Okay, so how can we use this to generate motion? Because this is just using some sort of static positioning to position our panel at this weird offset. Well, instead of using constant values such as 0 and 100 in these values, what we're going to do is we're going to use these variables that we created and this new variable that we created. So instead, we're going to say panel X is our starting position, and we're going to say panel target X is our ending position. And what's happening is by passing in a value that we then change, we start to generate motion. So we're passing in a dynamic value, and then we're setting that back to its original value and generating motion this way. Okay, so what is panel target X? Well, panel target X is going to be whatever we say it is. Right now it's 0. So if I run this, there's not going to be any sort of motion because it's saying, hey, start at its X and go to the same 0 position by 50%. And then return that back to our X position. Okay, well that doesn't mean anything. So let's say we set panel target X equals to 1,000 and we run the project. Now you'll see it was so fast, it lerped all the way to the right side of the screen. Basically, we couldn't even see it. So let's go ahead and turn down this amount. I usually use 0.1 or 0.2. I almost never use anything larger than those two values to lerp our values. Anything other than that tends to be very quick. So you'll notice that this is still pretty quick, and it's also relatively arbitrary in the sense that it happens every time we start it. So why don't we instead do this? We're going to say panel X. Let's change the order of this. We're going to create panel width first. And we're going to say panel X is equal to negative panel width. And panel target X is going to be equal to panel X also. All right, so we're going to say panel X and panel target X are the same value. We set this to negative width and we set this. So let's go ahead and run this again. And you'll see that our menu is hidden completely off screen to the left. And look, if you look really closely, we can see 1 pixel right here hugging the left side. So maybe we could be a little more precise and we could say -1. Okay, so now what we're going to do is we're going to say if our panel is open, panel target X equals 0, else panel target X equals negative panel width. Okay, so we're going to say if our menu is open, we're going to set our target X to be 0, and otherwise we're going to set it negative width. So we're going to send it way left off screen, okay? So we're going to say send way left off screen. Or we're going to send it to open. All right. So let's go ahead and press play again. And you'll notice that we have nothing here, but if I press enter, now what we're doing is we're lerping our panel X position to be 0. Now keep in mind we are drawing a rectangle, so the 0 position is the top, the panel X is the top left corner of this whole panel that we've created. Okay, so we're saying, okay, if it's open, we want this to be 0, and if we're closed, we're gonna go all the way to the left. So now what I can do is I can hit enter, and we have a nice smooth motion. And the reason that this is smooth is because as we get closer to our target, we start to move slower. And as we're farther from our target, we move faster. So you'll notice here that we have this nice initial kind of momentum, and then it slows down and does like a nice smooth motion exit. All right, so we can do this for all sorts of types of things. I just used this as an example because menus look really nice when you lerp everything. But you can use this for enemy movement. You can use this for item movement. You can use this for any sort of value or object or image or anything that's sliding it around the screen. You can lerp its position to get that smooth motion. And all you have to do a lerp, let's go through the steps one more time. You create an X position, a target X position, and then you lerp from your X position to your target X position. And this could be anything. This could be image X scale. Let's go ahead and implement this into another example. Let's go back to our gem, and we're gonna say our scale is actually gonna be equal to 0. So we're gonna draw this at a 0, X, and Y scale. And what I'm gonna do is I'm gonna say target scale equals 3. All right? So now when we're created, we're gonna say scale is 0 and target scale is 3. And in our step event, I'm gonna say scale. Okay, remember we set the value equal to the lerp of the value to the target, okay? Scale equals lerp of scale. This should be easy to remember. And then we're gonna say target scale, nice. And then the amount. And if we look down here, it does give us a little bit, GameMaker does try to help us out. This value 1 and value 2 isn't too descriptive, but the amount is, so you should be able to remember that this is starting, ending, and then the amount that we want. And in this one, I'm gonna say 0.5. All right, so now, and if we look at our draw, we see that our image X scale and Y scale already accounts in for our scale value. So now what we should do is on start, the gem should start tiny and it should lerp into size. Oh, I didn't even see it. It was all the way to the right. Let's run this again and let's look at the right spot. All right, so see, we have a nice slow lerp into the screen. Let's go ahead and make that speed though faster. So I'm gonna say lerp speed equals 0.1, and instead of passing in this constant, let's pass in this variable, and let's run the project again. And now you can see we have this scaling in effect. What we could do is we could say target scale is equal to 5, and then we're gonna say if scale is greater than 3, we're gonna say scale equals lerp of scale to 3 lerp speed. And let's go ahead and wrap this up. So now what we'll do is we'll grow to 5 and then we'll shrink back down. All right, let's take a look at it. If scale is less than 3, we want to lerp it to 3. Oh no, we want to say if scale is less than target scale, let's lerp to our target scale. Else scale, we're going to lerp it back down to the small one. And what's happening is as we get closer and closer and closer and closer, we're moving in smaller amounts, so it takes long to hit this condition. So what we actually want to do is we can just say absolute value of scale minus target scale. So now we're going to find the difference is less than or equal to 0.1. So what we're doing is we're saying instead of checking for this condition to be met, in which our value is equal to the target value, we're going to just check the difference. We're going to say, okay, is the distance between our scale and our target scale less than 0.1? And if it is, then that's good enough. It's going to be close enough to the target that the user won't be able to see the difference at that point, and we want to move on to the next step. So this is something you'll notice that if you get to a point where you're like, oh, I feel like this should be moving on to the next step or doing the next thing, and it's spending all this time lerping, it's because that distance gets smaller and smaller and smaller every time. So make sure you put in some sort of catch if you're waiting for that lerp to finish. That way you're not sitting here waiting for a long time. All right, guys, that's pretty much it for today's video. Like I said, it was just supposed to be a quick and dirty introduction to sine functions and lerping functions. So if you notice, we scale up really large and then we keep pulsating back down, and that's because we probably should put in some flag. Scaled equals false, and All right, so we only want this to happen once. All right, so you'll notice that we grow in really big, and then it takes a long time actually for our value for the gem to shrink down. And that's because this is one of the built-in limitations to lerping, and one of the ones that, the only really frustrating thing I would say that comes along with this technique is that, as I mentioned before, the closer we are to a target, the slower we move. So basically what we're doing is we're saying, hey, move 10% of that distance. So let's say you're at a 0, you want to move to 100. All right, so you say, let's move 10%. All right, so now you're at 10. All right, so now you're at 10 and now you want to move to 100. The distance is 90. You say, let's move 10% of that. Now you move forward 9. All right, now you're at 19 and you're going to 100. The difference is 81, and now you say move 10%. Now you move 8.1. So every time you move closer, you move in smaller and smaller increments. And as you get really close to your target and you move by smaller and smaller values, it starts to take a really long time to reach that target destination. In my last Loot 'em Dare game, you can see that I did this stuff all over the place. Everything is sign, everything is lerp. I mean, if we look at this right here, you can see that this menu moving at the bottom, this exit game, that's just got a sign function on it. This rotation is just a sign function. The rotation of this wave is a sign function. The rotation of this is a sign function. I mean, everything just has sign functions. The movement and the rotation of these waves is signs. We have our menus that are lerped. Everything is just sign and lerp, and pretty much every motion, I just lerped that rotation in and lerped that scaling in. I lerped in the edges and scaled those using sign. I mean, you could just tack this onto everything and it starts to make your games look more polished and like it has more motion. Anyway, guys, thank you so much. I hope you enjoyed. If you enjoyed the video, click the like button and subscribe, and I will upload another video sometime in the future.